my dear students. Let's start the session.
Focus here. KSA, floating body oscillations. For floating vertical cylinder, here to here, it's a cylinder. It's a cylinder. Vertical cylinder. Vertical cylinder. Height of the cylinder is capital H. Height of the cylinder is capital H. Capital H. Density of the body is rho B. Density of the body is rho B. Density of the fluid is rho F. Depth of immersion. This is called depth of immersion H. Center of buoyancy is the centroid of the displaced portion. Center of buoyancy. Centroid of the displaced portion. Here to here how much? H by 2. H by 2. Buoyant force always acted. Center of buoyancy. It is acting vertically upward direction. What is the buoyant force? Density of the fluid into volume of the fluid displaced into G. Clear? Weight of the body always acted. Center of gravity. Center of gravity. Weight of the body is acting at center of gravity. What is the buoyant force? Archimedes principle. Archimedes principle. Buoyant force. Buoyant force. This is the buoyant force. Buoyant force. What is the buoyant force? Tell me. As per basic definition is what? Weight of the fluid displaced. Weight of the fluid. Weight of the fluid displaced. Weight of the fluid displaced. Weight of the fluid displaced equal to weight of the, this is equal to how much? Density of the weight of the fluid displaced. Density of the fluid into volume of the fluid displaced into G. What is the volume of the fluid displaced? What is the volume of the fluid displaced? Volume of the fluid. Volume of the fluid displaced. That equal to how much? Volume of the body immersed in the fluid. Same volume of the fluid will be displaced. Volume of the body. Volume of the body. Volume of the body immersed in the fluid. Volume of the body immersed in the fluid. Volume of the body immersed in the fluid. Volume of the shaded portion is what? Volume of the body immersed in the fluid. What is the volume of the fluid displaced? This area will be A into small h. How much volume of the fluid displaced? Whatever the volume of the body immersed in the fluid, same volume of the fluid will be displaced. Now tell me, what is the buoyant force? Buoyant force can be written as density of the fluid into volume of the fluid into G. Volume of the fluid displaced into G. Buoyant force equal to density of the fluid into A into H into G. Now, under static equilibrium condition, weight of the body is balanced by buoyant force. Weight of the body balanced by buoyant force. Weight of the body balanced by buoyant force. Completed? Here, buoyant force. Another definition. Net vertical component of hydrostatic pressure force. Hydrostatic pressure force experienced by the body. Experienced by the body. Experienced by the body. Net vertical component of hydrostatic pressure force experienced by the body is defined as the buoyant force. Buoyant force always act vertically upward direction. The point of application of buoyant force is center of buoyancy. Center of buoyancy is the centroid of the displaced portion. This is the shaded portion is what? Displaced portion. What is the center of gravity? Centroid of the body. This is how much? Capital H by 2. This is how much? H by 2. Understood or not? Now tell me. Under static equilibrium condition. This part completed.
No, sir.
Under static equilibrium condition. Under static equilibrium condition, hydrostatics, the body is at rest. Sigma Fy equals to 0. Sigma Fy equals to 0. Sigma Fy equal to 0. Sum of the upward force equal to sum of the downward forces. Buoyant force is balanced by who? Weight of the body. Buoyant force equal to how much? Weight of the body. Weight of the body. So, density of the fluid. This is equal to how much? Density of the fluid into volume of the fluid displaced into G. Density of the body into volume of the body into G. Mass into volume. Density equal to mass by volume. Clear? This is how much? Now tell me, GG gets cancelled out. We can confidently write density of the fluid A into small h into G. Density of the body, volume is how much? What is the volume of the cylinder? A into h into G. Clear? Now tell me, density of the fluid by density of the fluid by density of the body equal to how much? Capital H by small h. Capital H by small h. What is the small h? Tell me here. Small h can be written as density of the body by density of the fluid into capital H. This is the depth of immersion of the fluid body. Depth of immersion of the body. Depth of immersion. Depth of immersion of the body in the fluid. In the fluid. Partially immersed. Floating body means what? A body partially immersed in the fluid. Depth of immersion. Floating body means what? Partially immersed. Body partially immersed in the fluid. Partially immersed in the fluid. Partially immersed in the fluid. Body partially immersed in the fluid. This is hydrostatics content. Hydrostatic content. Now we need to focus on hydrodynamics. Dynamics part. Oscillations. Completed. Dynamics part. Completed. Now, hydrodynamics. Floating body oscillations. Hydrodynamics. Hydrodynamics. Last case, this body just floating. Simply floating. It is not oscillating. Clear? The body is at rest in. Last case. Now hydrodynamics. What is the first step here? Completed. Here. So first we need to focus on First we need to focus on. Draw this figure again. Hydrodynamics. So what is the first step? The body, vertical cylinder is floating. So first step, draw this figure again. First we need to project the area onto the free surface. First to project the area. What kind of area you will get for cylinder? What kind of area you will get for the cylinder? Circular cross section. Circular cross section. Okay, this is the circular cross section. Take this part. Draw free body diagram for the element. Draw free body diagram for the element. Draw free body diagram for the element. Here to here. This. Here. Buoyant force. This buoyant force. Focus here. Here. We need to give the disturbance. Focus on this. This is the disturbance. We need to disturb the system. We need to disturb the system. Understood? Here. This is what? Depth of immersion. Depth of immersion. Here to here. There's one. This is the element. This is the element. Project the area. This is the element. Element. Mass of the element is m. This is the mass of the element m. Understood? So we need to disturb the system. We need to disturb the system. Disturb అంటే ఏంది? దీని పైన మొటిగా అయింది బట్ అనండి అది పైకి కిందకి ఆసిలేట్ అవుతా ఉంటది క్లియరా? సో we need to calculate time period of oscillation. We need to give the disturbance. Weight of the body is neglected. Weight of the body is neglected. Why neglected? I will explain later. Clearer in the method 2. Weight of the body. We should not represent weight of the element in the free body diagram. Okay now, what else associated with the element mass? Inertia force. Okay now, what are the things associated with element mass? Inertia force. Weight of the element mass. Weight of the element mass is neglected in floating body oscillations. What else remaining for the element mass? Inertia force. Inertia force always at opposite to the direction of motion. Inertia force equal to how much? Mass into acceleration. Mass into acceleration. Buoyant force acting on the element. See this, buoyant force. This is the buoyant force. Buoyant force equal to how much? Density of the fluid into volume of the fluid displaced into G. This much X is floating between the fluid surface. Total will come down, moving up, moving down, moving up, coming down, moving up. Understood? This much X is floating. Okay now, it is moving up and down. Now tell me, what is the buoyant force acting on this? Buoyant force acting on this, that equal to how much? What is the cross section? Circular cross section. Buoyant force equal to how much here? Buoyant force equal to how much here? Density of the fluid. Here volume of the fluid displaced equal to how much? A into X. A into X. Inertia force represented in the free body diagram means what? Dynamic problem converted into static problem. Apply static equilibrium equation. sigma Fy equal to 0. Sum of the upward force equal to sum of the downward forces. Inertia force plus buoyant force equal to 0. In this case, buoyant force acting as the restoring force, spring force, mass into x double dot plus density of the fluid into A, volume of the fluid displaced. Volume of the fluid displaced into G equal to 0. That equal to how much? Here, mx double dot plus density of the fluid into A into x into G. That equal to 0. M into x double dot plus density of the fluid into A into G into x equal to 0. Now take m to the denominator, x double dot plus density of the fluid into A into G by m. Clear? Into x equal to 0. So it represents what? SHM, simple harmonic motion. It represents or follows SHM, simple harmonic motion. So we need to compare with the SHM equation. Omega n square x equal to 0. Omega n square can be written as density of the fluid into A into G by m. Clear? Now tell me, omega n equal to written as omega n equal to how much square root of density of the fluid into A into G by m. Now, what is the time period of oscillation? 2 pi by t. So we can confidently write 2 pi by t. That equals to density of the fluid into A into G by m. So from here, time period of oscillation of the floating vertical cylinder, T equal to how much? Here, T equal to how much? 2 pi square root of m by density of the fluid into A into G. Clear? Time period of oscillation is, you can confidently write. Here you can write, this is previous year competitive exam question. T directly proportional to how much? Root m. T is inversely proportional to density of the fluid. T is inversely proportional to area. T is inversely proportional to G. Understood or not? So we can confidently write, what is this? K fluid. We can write it as stiffness of the fluid. Kf. Kf equivalents to how much? Kf equivalents to how much? Kf equivalents to how much? Density of the fluid into A into G. So we need to convert into spring mass system. What is the time period of oscillation? For spring mass system, T equal to 2 pi square root of m by k. In floating body oscillations, K fluid will come. Understood or not? Now, thus is the free surface. Method 1 completed. Now we need to apply method 2. How to solve floating body oscillations? By using method 2. By using method 2 completed. Understood or not? We have drawn free body diagram for the element. So first step, we need to project the area onto the free surface. Project the area onto the free surface. Project the area onto the free surface. Here, circular cross section ఇప్పుడు ఇలాంటి సిలిండర్ ని సబ్ కోసినాం అనుకో, ఒక ముక్క తీసుకున్నాం అనుకో, ఏ క్రాస్ సెక్షన్ వస్తుంది నీకు? సర్క్యులర్ క్రాస్ సెక్షన్ అంటారన్నమాట. అయిపోయిందా? ఇది పుచ్చకాయని కోసినాం అనుకో, మధ్యలో ఏమొస్తుందా? సర్క్యులర్ క్రాస్ సెక్షన్. పుచ్చకాయ తెలుసా? పుచ్చకాయ క్లియరా? సబ్ కోసినాం అనుకో, మధ్యలో క్రాస్ సెక్షన్ ఏందా? సర్క్యులర్ క్రాస్ సెక్షన్. ఓకేనా? మైసూర్ పాకును కోసినాం అనుకో, ఏమొస్తుందా? స్క్వేర్ క్రాస్ సెక్షన్. దట్ ఈస్ ద క్యూబ్. రెక్టాంగులర్ కార్లో పైపు అనకండి. ఓకేనా? మైసూర్ పావుకు క్యూబ్ గా ఉన్న మైసూర్ పావుకే తీసుకొని పోయండి. క్లియరా? క్యూబ్. పాలకోవా తీసుకోండి, క్యూబ్. క్యూబ్ అంటే దట్ స్పియర్, వర్టికల్ సిలిండర్, కోన్. టోటల్ 3 కేసెస్. మనకి ఇక్కడ స్వీట్ ఏది ఇంపార్టెంట్ కాదు, క్రాస్ సెక్షన్ ఇంపార్టెంట్. దట్ ఈస్ వాట్? హాలో డిస్క్. హాలో సర్క్యులర్ డిస్క్, హాలో డిస్క్. కంప్లీటెడ్. మనకి ఏది అవసరం లేదో దాని మీదే ఎక్కువ ఫోకస్ ఉంటుంది మనకి. మనం ఫోకస్ చేయాల్సింది మైసూర్ పాకు మీద, క్రాస్ సెక్షన్ మీద. క్రాస్ సెక్షన్ మీద ఫోకస్ ఉండాలి. క్లియరా? నౌ టెల్ మీ.
సార్ సేమ్ డయాగ్రామ్ రిపీట్ చేద్దాం.
నెక్స్ట్ రైట్ డౌన్ సేమ్ డయాగ్రామ్. నౌ we need to draw the method 2. See here how to solve these questions straight away. This is the concept. ఐఐటి గౌహతి ఉంటది కదా, ఐఐటి గౌహతిలో ఎర్త్ ప్లేట్స్ వస్తాయి అన్నమాట. మేము ఫస్ట్ లో జాయిన్ అయినప్పుడు ఐఐటి గౌహతిలో నేను 15 రోజులు క్లాసులు పోయింది. తర్వాత ఐఐటి కాన్పూర్కి వెళ్ళాం. అక్కడ ఆడికి వెళ్ళినప్పుడు సడన్ గా వణుకుద్ది బిల్డింగ్, అంతే కదా. ఎర్త్ ప్లేట్స్ వచ్చినప్పుడు అప్పుడు మనం ఏంది, నేనైతే బుక్ తీసుకొని పరుగు. అర్థమైందా? ఆ టైంలో వీళ్ళు ఉంటారు కదా, పెద్ద సీనియర్ పిహెచ్డి అన్న వాళ్ళు ఉంటారు కదా, వాళ్ళు గమ్ము కూర్చోన్నారు. వాళ్ళకి అలవాటు అయిపోయింది. మామూలుగా రెగ్యులర్ గా వస్తూ ఉంటాయి. మినిమం ఒక వారానికి ఒకటి వస్తూ ఉంటుంది. మామూలు అటు సైడ్ నేపాల్ అవన్నీ కామన్. ఆ అస్సాం ఉంది కదా, అక్కడ ఎర్త్క్వేక్స్ కామన్. కానీ ఆ బిల్డింగ్లు అన్నీ మొత్తము గేర్లు ఉంటాయి, అన్ని క్రాక్స్ వచ్చేసి ఉంటాయి. ప్రతి బిల్డింగ్ క్రాక్ వచ్చి ఉంటాయి. ఏం బావు, వాళ్ళు కరెక్ట్గానే కడతారు. బిల్డింగ్ కట్టేటప్పుడు ఆ ఏరియాలో చూసుకొని ఎర్త్క్వేక్స్ ఆ పాయింట్ ఉంటుంది, ఆ పాయింట్ బట్టే బిల్డింగ్ కడతారు. మనము 7 పాయింట్ వరకు కట్టి పెడతారు. 6 పాయింట్ ఎంతో వస్తుంది, 7 దాకా వచ్చిందంటే అది చాలా పెద్ద ఎర్త్క్వేక్. అది అంత వస్తే ఇంక పోతాయి మొత్తం. అప్పుడు గోయిందార్థం. మనం పరిగెత్తినా ఏం పరిగెత్తుతావు నాకు అర్థం కాదు. నువ్వు పరిగెత్తినవే అనుకో, యాడికి పరిగెత్తుతావు? ఎర్త్క్వేక్ ఏమైనా గంటసేపు ఉంటుందా? సెకండ్స్లో వెళ్ళిపోతుంది. అర్థమైందా? సిఆర్ ఫోకస్ హియర్. నౌ సీ దిస్ method 2. How to solve floating body oscillation questions straight away. చెప్పండి. How to build the mathematical model. Focus on this. Here to here. This body, vertical cylinder is floating. Take data from JEE advanced question. One JEE advanced question. H equal to h by 2 given. H equal to h by 2 given. This is capital H. This is capital H. First, as a first step, what we need to do? Project the area onto the free surface. Project the area onto the free surface. This is X. Mass of the element is M. Okay now, mass of the element is M. Now, mass of the element is M. First what we need to do? Take this. We need to convert it into the spring mass system. We need to convert it into the spring mass system. Convert it into this much story not required. See here. Convert it into the spring mass system. This is the spring mass system. So this is the element mass. Element mass. Total fluid replaced with the spring. Fluid replaced with the spring. Fluid replaced with the spring. What is the stiffness of the fluid? Stiffness of the fluid. Stiffness of the fluid. Density of the fluid into A into G. Density of the fluid into A into G. Are you clear or not? Understood this? Density of the fluid into A into G. What is the time period of oscillations? Time period of oscillations. Time period of oscillations. Time period of oscillations. So now you understood now why we neglected weight of the fluid. Now why we neglected weight of the element mass. Weight of the element mass. Deformation in the spring. Both are in the same direction. That is why weight of the element mass is neglected. Okay now. So now tell me what is the time period of oscillation? T equal to 2 pi square root of T equal to T pi square root of M by K. This is K fluid. K fluid. So what is the area of cross section? A. A is the area of cross section. K fluid equal to density of the fluid into A into G. Now what is the mass? Mass nela rayachuppo. Mass equal to how much? Density of the body into volume of the body into, that is volume of the body, that's it. M equal to how much? Density of the body into A into capital H. Understood? Now tell me straight away, time period of oscillations 2 pi square root of density of the body into volume of the body. This is density of the fluid into A into G. M by Kf. Huh? Mass of the, this is what? Mass of the fluid. Mass of the entire fluid. Okay now? Mass of the body only. That is mass of the body. Element mass. Entire cylinder is oscillating. Take the element. Okay now? Take the element. This is the oscillation. This is the disturbance. This is the disturbance. Clear? This much volume of the fluid at interface. This much volume of the fluid at interface. But M is what? Mass of the body. M is the mass of the cylindrical body. Entire ఈ సిలిండర్ మొత్తాన్ని ఎలిమెంట్ మాస్ గా ఫోకస్ చేయాలి. కింద ఉన్న ఫ్లూయిడ్ మొత్తాన్ని స్ప్రింగ్ గా రీప్లేస్ చేయాలి. అర్థమవుతుందా? ఈ పర్టికులర్ సిలిండర్ ని ఇక్కడ పెట్టాలి. క్లియరా? సో మాస్ ఆఫ్ ద సిలిండర్, మాస్ ఆఫ్ ద సిలిండర్, మాస్ ఆఫ్ ద సిలిండ్రికల్ బాడీ. అండర్స్టూడ్ ఆర్ నాట్? ఇక్కడ ఏం లేదు. ఫస్ట్ ఈ ఫ్రీ సర్ఫేస్ కి ఏరియా ప్రొజెక్ట్ చేయాలి, దాన్ని ఇక్కడ పెట్టేయాలి. అర్థమవుతుందా? దాని తర్వాత కింద ఉన్న ఫ్లూయిడ్ ఉంటుంది కదా, ఫ్లూయిడ్ మొత్తం లేపేసి స్ప్రింగ్ పెట్టాలి. ఫ్లూయిడ్ మొత్తం లేపేసి స్ప్రింగ్ పెట్టాలి. క్లియరా? సో నౌ టెల్ మీ, AA gets cancelled out. Time period T equal to how much? 2 pi square root of 2 pi square root of how much you are getting? Density of the body is A. This A gets cancelled out. M by Kf. Density of the body by density of the fluid equal to how much? H equal to how much? Density of the body by density of the fluid into capital H. capital H. Understood? So now tell me H equal to how much? H by 2. H by 2 equal to how much? Density of the body by density of the fluid into H. అక్కడ ఏముంది మనకి density of the body by density of the fluid ఎంత? Density of the body by density of the fluid equal to H by H equal to how much? H by 2 by H. Density of the body by density of the fluid equal to how much? 1 by 2. 1 by 2. Replace density of the body by density of the fluid with 1 by 2. Then H by 2G will come. Replace this with 1 by 2. Clear? H by 2G will come. This is the time period of oscillation for the floating cylinder. Vertical floating cylinder. Vertical floating cylinder. Clear or not? Vertical floating cylinder. Here, this area and this area both are same. Here, this area is what? This area is what? Area projected. This is the area projected onto the free surface. Area projected. Area projected onto the free surface. 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 This is the base area of the cylinder. Base area of the cylinder. This is very important. Okay na? K fluid equal to, in this, what is this area? Area projected onto the free surface. Area projected onto the free surface. Area projected onto the free surface. This is the base area. Base area of the cylinder. Okay na? In this case, both areas are same. In this case, both areas are same. Area projected onto the free surface. This is how much? A equal to pi r square. What is the base area? What is the base area? That is also pi r square. For example, if you take a core, area projected onto the free surface different, base area different. Understood? So in this particular case, in order to calculate Kf, take the projected area only. Area projected onto the free surface. P equal to 2 pi square root of H by 2G. Completed. Next, coming to the for floating sphere. For floating sphere, when the sphere is floating, focus here. When the sphere is floating, you need to calculate time period of oscillations for floating sphere. For floating sphere, if the sphere is floating, for floating sphere what you will get? Focus here. This is the sphere. Sphere is floating. Okay na? So this case,
Sir, same case of case B.
case B. This is case B. Half of the sphere is floating over the free surface. This is the here to here. This is the cross section. What is the area of cross section of projected area? How much? Pi r square. First we need to write projected area. So half of the sphere is floating. This is how much? Depth of immersion is how much? R by 2. R by 2. R by 2. Clear or not? So now tell me, first thing we need to take this circular cross section. And then we need to replace the entire fluid. We need to replace the entire fluid with KF. With KF. KF equal to how much? Density of the fluid into area projected onto the free surface into G. Into G. Mass of the, this is the element mass. Mass of the sphere. Mass of the sphere. If you apply dynamics, if you apply hydrostatics, buoyant force and G. Buoyant force is, this is the area of the shaded portion means what? Displaced area. This would be displaced area. Area of the displaced portion. Buoyant force. Weight of the body. Buoyant force. Density of the fluid into volume of the fluid displaced into G. Volume of the fluid displaced equal to half of the volume of the fluid. So here, sum of the upward force equal to sum of the downward forces. ఏమొస్తుంది చూడండి ఇక్కడ buoyant force equal to how much? Buoyant force equal to how much? Weight of the body. Weight of the body. Now, density of the fluid into volume of the fluid displaced into G equal to weight of the body into volume of the body into G. Clear? What is the volume of the fluid displaced? Volume of the sphere immersed in the fluid, that is V by 2. Volume of the sphere immersed in the fluid, that is V by 2. Then what we will get? This G gets cancelled out. So we can write it as density of the fluid into V by 2 equal to density of the body into V. Density of the body by density of the fluid equal to how much? Density of the body by density of the fluid equal to how much? 1 by 2. 1 by 2. Are you getting the same? This is hydrostatics. Hydrostatics. Time period of oscillation. Time period of oscillation. T equal to how much is obtained? T equal to how much is obtained? 2 pi square root of M by K fluid, stiffness of the fluid. Okay, T equal to how much? 2 pi square root of density of the body into volume of the body into G by volume of the body into G by. What is this? Density of the fluid. Density of the fluid into A into G. What is the volume of the body? Volume of the body equal to how much? Volume of the sphere. Volume of the body is nothing but volume of the sphere. Radius is R. 4 by 3 pi r cube. 4 by 3 pi r cube. What is the area of the projected portion? Pi r square. Density of the body by density of the fluid equal to how much? 1 by 2. 1 by 2. So now we can confidently write T equal to how much? 2 pi square root of this G gets cancelled out. Then density of the body by density of the fluid equal to how much? 1 by 2. This is how much? 4 by 3 pi r cube. 4 by 3 pi r cube by pi r square. Are you getting the same? Volume by area how much? 4 by 3 pi r cube by pi r square. Pi r square, 2 gets cancelled out. Then T equal to 2 pi square root of how much is obtained? 2r by 3g. Where is g? This is g. Are you following? This is how much? 2r by 3g will come. 2r by 3g will come. This is the time period of oscillation for sphere. 2 2 jar, pi r square. 2r by 3g. 2r by 3g. Perfect. Correct or not? Are you getting the same? Floating sphere. Now coming to the floating cube. For floating cube. For floating cube. Completed. So half of the sphere is immersed in the fluid. Half of the sphere is floating above the free surface. floating above the free surface, buoyant forces acting upward direction. This is weight of the sphere. Weight of the sphere. Weight of the sphere. Huh? Now okay, G won't come. Mass is nothing but density of the body into volume. Mass is the density of the body into volume of the sphere. Density of the body into volume of the sphere. Density of the body by density of the fluid equal to 1 by 2. Volume 4 by 3 pi r cube. A is pi r square. G. 2 2 jar. Pi r square. 2 r by 3 G. Completed. Next item. For floating cube. For floating cube. KC. Floating cube. This is how much? Floating cube. Cube is floating. Here to here. It's a cube. This is the cube. You can take H. Depth of immersion is H by 2. Depth of immersion is H by 2. Volume of the, this is what? When you project the area, what you will get, tell me. So when you project it, what you will get? So weight acting exactly here. Buoyant force is acting here. Weight of the cube is acting downward. Buoyant force is acting upward. Weight of the cube is acting downward. Weight of the cube is acting downward. This is weight of the cube. So now tell me, weight of the cube. So half of the volume of the cube. Understood? Half of the volume of the cube. Same story will come. Here also same story. Volume of the fluid displaced. Half of the volume of the cube. Immersed in the fluid. So first step anybody. We need to project it onto the free surface. Clear? We need to project the area onto the free surface. What kind of area you will get? Square cross section. What kind of area you will get? Square cross section. This is the area. Area equal to how much? H square. Area equal to how much? H square. So mass of the element is here. Area projected onto this. Density of the body into volume of the cube by density of the fluid into A into G. Density of the body by density of the fluid 1 by 2. What is the volume of the cube? H cube by. This is H square into G. Are you following? Understood or not? T equal to 2 pi square root of 1 by 2 H cube by H square into G. Clear? Now tell me how much is obtained? T equal to how much? 2 pi square root of H by 2G. Okay na? T equal to 2 pi square root of H by 2G. All are following. Half of the volume of the fluid is KC. Half of the volume of the cube is immersed with the fluid. అర్థమవుతుందా? అర్థం కావట్లే? మీరు ఇప్పుడు వచ్చారా? అటుగా బాబు ఇందాక నుంచి వినేరు కదా, క్లాస్ అర్థమైందా లేదా? ఇప్పుడు నువ్వు చెప్పండి, ఇది ఈక్వేషన్ రాయడం వస్తుందా లేదా? దీని తర్వాత ఇది వచ్చిందా? ప్రొజెక్ట్ చేయడం వచ్చిందా? ఏరియా ఆఫ్ ద ప్రొజెక్టెడ్ పోర్షన్ ఎంత? x స్క్వేర్. ఏరియా ఆఫ్ ద ప్రొజెక్టెడ్ పోర్షన్ x స్క్వేర్. దీన్ని మాస్ ఆఫ్ ద ఎలిమెంట్ గా రాయాలి. m is the mass of the cube. m is the mass of the cube. k fluid. density of the fluid into a into g. ఓకేనా? ఫైనల్లీ h by 2g. h by 2g. In this case1, in this one, now we can write 2. In this case2, direct to previous year question, h by 3 is given. చూడండి ఇక్కడ h by 3 is given. h by 3 is given. అదే రాసారబ్బా పై క్వశ్చన్ లో కూడా, అర్థమైందా? సో ఇప్పుడు చూడండి, డెన్సిటీ ఆఫ్ ద ఫ్లూయిడ్ ఇంటూ a into what is the how much volume of the fluid is displaced, h by 3, that equal to how much? Density of the body into a into h. Density of the body by density of the fluid equal to how much? 1 by 3 will come. Density of the body by density of the fluid equal to how much? 1 by 3.
Sir, as like sir,
ఇక్కడ 1 by 3 కానిస్తే అక్కడ లాస్ట్ లో 1 by 3 వస్తుంది. 1 by 3 ఇస్తే 1 by 3 వస్తుంది. 1 by 3 given in the JEE advanced question. 1 మ్యాచింగ్ ఇచ్చారు. 3 అయిపోయింది. 4th one ఉంది ఆ JEE advanced క్వశ్చన్. ఒక క్వశ్చన్ మొత్తం మ్యాచింగ్ టైప్. ఫస్ట్ లెఫ్ట్ కాలంలో ఉంటాయి, అర్థమైంది కదా? ఈ 3 లెఫ్ట్ కాలంలో ఉంటాయి. ఆ క్వశ్చన్ మళ్ళా చూపిస్తాము. ఇంకొకటి మిగిలింది, అది కోన్ మిగిలింది. కోన్ ఒకటి, ఫ్లోటింగ్ బాడీ ఆసిలేషన్స్ ఇన్ ద నానోమెట్రిక్ ఫ్లూయిడ్. 2 cases pending. So here in this case C, h by 3 ఏమి ఇచ్చినా చేయగలగాలి. క్యూబ్ అయినా స్పియర్ అయినా మనం ఎప్పుడు కూడా ఎగ్జామ్లో ఎలా ఇస్తారంటే కార్టీషియన్ కోఆర్డినేట్ సిస్టమ్, సిలిండ్రికల్ కోఆర్డినేట్ సిస్టమ్, స్పెరికల్ కోఆర్డినేట్ సిస్టమ్, ఎంటైర్ ఏ కేసు అయినా ఎత్తుకోండి. నువ్వు ఎంటైర్ ఫిజిక్స్, ఎంటైర్ ఇంజనీరింగ్, మనం మొత్తం రీసెర్చ్లో మనం దేని మీద వర్క్ చేస్తామా? కార్టీషియన్ కోఆర్డినేట్ సిస్టమ్, సిలిండ్రికల్ కోఆర్డినేట్ సిస్టమ్, స్పెరికల్ కోఆర్డినేట్ సిస్టమ్, ఏ టాపిక్ అయినా ఈ 3 కోఆర్డినేట్ సిస్టమ్ని కవర్ చేయాలి. దిస్ ఈజ్ వాట్ కార్టీషియన్ కోఆర్డినేట్ సిస్టమ్. వర్టికల్ సిలిండర్, cylindrical coordinate system, sphere, spherical body, spherical coordinate system. అలానే వస్తాయి. కెపాసిటర్ లైన్ అవే వస్తాయి. మళ్ళా థర్మోడైనమిక్స్, థర్మల్ ప్రాపర్టీ ఆఫ్ మ్యాటర్. దాదాపుగా నువ్వు సిలబస్ ఎత్తుకుంటే నువ్వు కేసెస్ డిస్కస్ చేసేటప్పుడు ఈ 3ని ఫోకస్ చేస్తావు. దట్ ఈస్ ఫిజిక్స్. ఫిజిక్స్ కాదు, బేసిక్ కామన్ సెన్స్. ఈ 3ని అనలైజ్ చేయాలి. అప్పుడు నీకు బాడీస్ మీద కమాండ్ వస్తుంది. క్లియరా? ఓకేనా? యూ కెన్ మీట్ ఇన్ ద నెక్స్ట్ క్లాస్. సో ఫోకస్ హియర్. ఫర్ దిస్ కేస్ 3 will come. For this case 3 will come. h by 3g, h by 3 is there, h by 3 will come. And a conical body is floating over the free surface. See here, this is the conical body. Conical body floating on the free surface. Here, area projected onto the free surface, circular cross section. What is the height of the cone? This is the height. Here to here, this is given as capital H by 4. This is capital H. Height of the cone, depth of immersion when center of gravity coincide with the free surface, it is at H by 4. It is at capital H by 4. Clear? So here area of this particular volume of the displaced portion. This is a displaced portion. Center of gravity. This is how much here? Here to here. Conical. Center of buoyancy here. Center of buoyancy. Buoyant force always act vertically upward direction. Buoyant force always act vertically upward direction. This is H by 4. H by 4. Okay na? Weight always act vertically downward direction. Weight of the body always act vertically downward direction. Here, see this. You can take the triangle. You can take the triangle here to here. You can take the triangle. Similar triangle concept of here H by 4 depth is immersed in the fluid. H by 4 is immersed in the fluid. Clear? So if it is H by 4, total will be, this is the radius R. This could be R star. This would be R star. Tan theta equal to tan theta. Concept of similar triangles. Concept of similar triangles. This is capital H. Capital H. From here to here, H by 4. From here to here, H by 4. Tan theta equal to tan theta. What you will get, tell me? From concept of similar triangles, tan theta equal to tan theta. Then R star by depth of immersion. Depth of immersion, that equal to how much? R by capital H. R by capital H. R star equal to how much? R by H into small h is nothing but H by 4. That equal to R by 4. R star is obtained. R by 4 is obtained. Clear? R star is nothing but R by 4. Area projected onto the free surface. A star equivalents to pi. R star square. Area projected onto the free surface. Now we can apply hydrostatics content. Okay na? Buoyant force is balanced by weight of the body. What is the volume of the cylinder? What is the volume of the conical body? 1/3 of the volume of the cylinder. 1/3 of the volume of the cylinder. Clear? So now tell me, what is the 1/3 of the volume of cylinder? 1/3 of the pi R square capital H. That is volume of the core. Volume of the conical body. Clear? So this is 1/3 of this. Now tell me, what is the volume of the shaded portion? 1/3 of the pi R star square into small h. 1/3 of the R star square into small h. Now we need to talk about hydrostatics. R star equivalents to how much? R by 4. In this case, how much? What is given in the question? H by 4 depth of the cone. H by 4 of the cone is immersed in the fluid. H by 4 is the depth of immersion mentioned in the question. Clear? Now we can apply. Completed. R star equal to how much? R by 4. Now buoyant force is balanced by weight of the body. Then what is the density of the body? Density of the body and density of the fluid. Density of the body and density of the fluid. This is the free surface. Clear? Now tell me, weight of the body is balanced by hydrostatics. Sigma Fy equal to 0. Buoyant force equals to weight of the conical body. Weight of the conical body. Buoyant force equal to how much? density of the fluid into volume of the fluid displaced into G. Density of the body into volume of the body into G. Clear? Now tell me what is obtained? Density of the fluid. This is 1/3 of the pi r star square into small h. This G gets cancelled out. Density of the body into 1/3 of the pi r square capital H. Pi r square capital H. Then 1/3 pi by 3 cancelled out. Then density of the fluid r by 4 whole square into h by 4 density of the body into r square into capital H. H equal to small h equal to h by 4. How much is obtained? Density of the fluid by 64. That equal to density of the body. Density of the body by density of the fluid is how much? Density of the body by density of the fluid is how much? 1 by 64. 1 by 64. Now we need to apply dynamics. Clear? Completed. Density of the body by density of the fluid equal to how much? Density of the body, conical body by density of the fluid 1 by 64 is obtained. 1 by 64 is obtained. Now we can apply dynamics. Completed. R star equal to how much? R star equal to how much? R by 4. R star equal to how much? R by 4. Now we need to replace the mathematical modeling of the system. Mathematical model of the system. Replace entire mass with area projected onto the free surface. Replace the water with spring because buoyant force act as the spring force or restoring force. Okay na? That is the mathematical modeling of the floating body oscillations. Mathematical modeling in floating body oscillations. First area projected onto the free surface. Here to here. This is the element. This is the element. Here to here. This is the element. This is the element. Mass will be m. Replace the fluid with a spring. With a spring. What is the stiffness of the fluid? Stiffness of the fluid equal to density of the fluid into G into A. G into A. Here we need to disturb the system. Disturb the system. Area is A star. Area projected onto the free surface. Here what is obtained? A star. Area projected onto the free surface. Now tell me here. What is the time period of oscillation? 2 pi square root of m by k fluid. K fluid. 2 pi square root of m by k fluid. T equal to 2 pi into, how to write m? Density of the body into volume of the body by density of the fluid into G into A star. G into A star. Time period of oscillation T equivalents to time period of oscillation T equivalents to, how to write, tell me? 2 pi square root of density of the body by density of the fluid can be replaced with 1 by 64. Clear? Now tell me, what is the volume of the conical body? What is the volume of the conical body? Tell me, 1/3 of the pi r square into capital H by G into A star can be written as pi r star square. Pi r star square. Then finally what is obtained? 2 pi square root of 2 pi square root of 1 by 64 into 3. Pi gets cancelled out. R square into H by R by 4. R by 16. R square by 16. R by 4 whole square. R star equal to how much? R by 4 whole square. R by 4 whole square. Then what is obtained? Tell me. 2 pi square root of 1 by 64 into 3. R square gets cancelled out. Here denominator what you will get? R square by 16. 16 4 jar. Here 4 3 jar 12. Finally, what is the time period of oscillation? Tell me. 2 pi square root of H by 12G. H by 12G. Clear or not? Understood or not?
T is equal to
2 pi square root of H by 12G. Here G will come. Here G will come. H by 16 4 jar 4 3 jar 12. H by 12G. What is the final answer to this question? T equal to 2 pi square root of H by 12G.
1.2.
Next data. Time period of oscillation in nanometer. Nanometer. Actually, the center of gravity H by 4 from the bottom anukunta. H by 4 from the bottom. Here. H by 4 from the top column. Depth of immersion is H by 4. Depth of immersion is H by 4. Conical law. Cone law H by 4 from the bottom. Center of gravity. Clear? Understood? It won't affect entire story. Depth of immersion mentioned in the question. Clear? Next data. Time period of oscillation in nanometers. Nanometer. Take manometer. Here height of the fluid column is H. Length of the fluid column is 2H. So we need to express time period of oscillation in terms of length and height of the fluid column. So here oscillations in manometers. Time period of oscillation in nanometer. Nanometer. Okay, the fluid present in the manometer, if it is oscillating, what is the time period of oscillation? Take manometer. See here, take manometer. This is the manometer. You know manometers. YouTube manometer. Manometer తెలియదు మనకి అసలు వినలేదా మానోమెట్రీనే రాదా అసలు మానోమెట్రీ అంటే తెలీదా ఓకే యూట్యూబ్ మానోమీటర్ దిస్ ఇస్ ద యూట్యూబ్ అంటే యూ షేప్ లో ఉన్న ట్యూబ్ అని యూ షేప్ లో ఉన్న ట్యూబ్ అనేసి దిస్ ఇస్ ద యూట్యూబ్ మీరు చూసే యూట్యూబ్ కాదు క్లియరా క్లియరా ఏమైంది నానోమీటర్ నానోమెట్రీ it is the branch of science which deals with study of measurement of the fluid measurement of pressure measurement clear nanometer see this fluid column if you pour the fluid both are exposed to atmospheric pressure that is why both fluid columns must be same single fluid here, pour fluid here. This is the fluid. This is the fluid. This is the fluid. Height of the fluid column. What is the height of the fluid column in left limb? Left limb lo height anta small h anukunte. What is the height of the fluid column in right limb? Right limb lo height anta untadi h untadi. Clear ah? It side h aithe at side kuda h untadi. What is the length of the fluid column? L equal to 2h. What is the length of the fluid column in manometer? Length of the fluid column. Length of the fluid column in length of the fluid in the manometer. Fluid column. Length of the fluid column in length of the fluid column in manometer. Manometer. H is the length of the fluid column in left limb or height of the fluid column in left limb. Height of the fluid column in left limb. Height of the fluid column in left limb. Left limb and right limb both are same. What is the weight of the fluid present in the manometer? First step, weight of the fluid present in the manometer. Weight of the fluid or mass of the fluid present in the manometer. Weight of the fluid in the manometer. Entire manometer. What is the weight of the fluid? దీని ఏం చేస్తారంటే ఇట్లా అర్థం చేయండి. ఇట్లా అనండి, ఒక ట్యూబ్ వస్తుంది కదా, ఆ ట్యూబ్ లో ఎంత హైట్ ఉంటుందా? ఒక ట్యూబ్ వస్తుందా? ఒక ట్యూబ్ లో మొత్తం వాటర్ ఎంత వరకు ఉంటుందా? వాటర్ ఎంత ఉంటుందా? దిస్ ఇస్ ద లెంగ్త్ ఆఫ్ ద ఫ్లూయిడ్ కాలమ్. L equal to how much? 2h. L equal to how much? 2h. What is the weight of the fluid present in? Total weight of the fluid present in the manometer. That is how much? Total weight is how much? Weight of the fluid. That equal to weight from the weight density is obtained from weight density. Weight density. What is the weight density? Tell me. What is the weight density? Weight of the fluid per unit volume. Weight of the fluid per unit volume. Gamma equal to weight by unit volume equal to rho g. Gamma equal to rho g. Weight density equal to rho g. Weight by volume means what? Mass by volume density. Mg by volume. M by V is density. Rho g. What is the weight of the fluid? Mass of the fluid into g by what is the volume of the fluid occupied here? Area into how much? Area into how much? L. Area into L. That equal to how much? Rho g. This is the density of the fluid. Gg cancelled. What is the mass of the fluid? Density of the fluid into A into L. So mass of the fluid equal to how much? Density of the fluid into A into 2H. This is the mass of the fluid. Total mass of the fluid present in the manometer. Total mass of the fluid present in the manometer 2 times of density of the fluid into A into small h. We need to disturb the question. We need to disturb the system. Then only the entire part is what? Hydrostatics. Entire discussion is what? Hydrostatics. Completed. Now we need to apply the dynamics. ఓకే, ఇది ఆసిలేట్ అవ్వాలంటే ఏం చేయాలి? ఇట్లా పట్టుకొని ఊపాలి. క్లియరా? ఇట్లాని ఇట్లన్నీ అనుకో, అప్పుడేమైద్దా? ఇట్లన్నీ అనుకో, ఈ వాటర్ కిందకు వస్తుందా, ఈ వాటర్ పైకి వస్తుందా, మళ్ళా ఆ వాటర్ కిందకు వస్తుందా, ఆ వాటర్ పైకి వద్దా, అప్పుడు వాటర్ ఎట్టా ఇది ఆసిలేట్ అవుతుంది కదా, ఇది కిందకి ఇది పైకి, మళ్ళా ఇట్లా 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 ఆసిలేట్ అవుతుంది కదా, అప్పుడు మనం టైం పీరియడ్ ఆఫ్ ఆసిలేషన్ కనుక్కోవాలి. క్లియరా? అర్థమవుతుందా? దిస్ పార్ట్ ఈస్ ప్యూర్ స్టాటిక్స్. నౌ weight density. So now we need to disturb the question. We need to apply dynamics. Disturb the question. X is the disturbance. X is the disturbance. Here to here. X is the disturbance. X is the disturbance. This is initial position. Initial position. Initial equilibrium position. Initial position is equilibrium position. System is under static equilibrium condition. System is under static equilibrium condition. Completed.
No, sir.
Now, X fluid is coming down. Then X fluid will move up. Okay na? X fluid is coming down. Then X fluid will move up. X fluid is coming down in the sense X fluid will move up. Now, here to here, this is the manometer. After giving disturbance, you gave disturbance, you disturbed the water, then oscillations will come. You disturbed the water, oscillations will come. This is the oscillation, time period of oscillations. Okay, so here water will go up to here.
Sir, అది
So ఇప్పుడు మనకు వాటర్ ఎట్లా పడదు చూడు, ఇట్లా పోయిందా. So this is the initial position. Okay, so water, this is the final position. Understood? So ఇప్పుడు మనకి కిందకి x, ఇటు x, ఈ పైకి x, టోటల్ హైట్ ఎంత అవుతుంది? So this is x. So we need to draw free body diagram for this fluid. అర్థమవుతుందా? ఎంత ఇటు సైడ్ నుంచిది? Yes. Here to here. Yes. Okay. So x, 2x. From here to here how much? 2x. X down and x up. Total 2x. Now we need to draw free body diagram for this. We need to give the disturbance. Free body diagram for this. Here to here. So we need to enlarge this part. Here to here. 2x. So mass of the fluid. This is the mass of the fluid. Entire part. This is the spring. Kf. So here it is 2x. Understood? This part completed. ఇది ఆల్రెడీ ఎప్పుడో జమాన కాలంలో రాశారు దీన్ని. ఇది ఎప్పుడు రాశారు? చాలా రోజుల క్రితం రాశారు దీన్ని.
చాలా రోజుల క్రితం యాడ్ సార్.
చూడండి ఇక్కడ. క్లియరా? సో హౌ టు డ్రా ఫ్రీ బాడీ డయాగ్రామ్. This is the mass M. We need to give disturbance. X is the disturbance. If I give disturbance, weight is balanced by static force. Now, inertia force will be acting. Inertia force always act opposite to the direction of motion. Next, here, buoyant force is acting. density of the fluid into G, volume of the fluid displaced. Volume of the fluid displaced into G. How much volume of the fluid displaced here? How much volume of the fluid displaced here? This is the area A. Area of the projected portion into 2x into 2x. X down and x up. Total volume of the fluid displaced. Volume of the fluid displaced. A into 2x. This much volume of the fluid displaced. How much volume of the fluid displaced? This much volume of the fluid displaced. Inertia force represented. Just now we discussed M equal to how much? 2 times of density of the body. Here density of the body also fluid. Here density of the body also fluid. Clear? This is how much? A into small h. Density of the fluid into A into 2h. Clear? So here sigma Fy equal to 0. Sigma Fy equal to 0. Then what is obtained here? Inertia force plus buoyant force equal to 0. Inertia force plus buoyant force equal to 0. Then mx double dot plus density of the fluid into G into A into 2 into x, that equal to 0. Here you can write volume of the fluid displaced into G. Volume of the fluid displaced into G. Mass can be replaced with density of the fluid into volume. What is the volume? A into 2h into G. A into 2h. X double dot. A into 2h is the total length of the fluid column plus density of the fluid into A into how much volume of the fluid displaced into G equal to 0. Into G equal to 0. Here the G won't come. Mass only. Here density. Here this 2A into density of the fluid. 2A into density of the fluid cancelled. 2A into density of the fluid cancelled. Then H x double dot plus Hx double dot plus x G into x that equal to 0. X double dot plus G by H into x equal to 0. H is the height of the fluid column in the left limb or right limb. So this follows SHM. Density of the fluid into A into G. Density of the fluid into A into G. Are you clear or not? Understood this? Completed. Here two fluids. Two was the clear? So completed. That means this. We need to compare with x double dot plus omega n square x equal to 0. Omega n square x equal to 0. Omega n square x equal to 0. Then here these two fluids connected in these two fluids వస్తాయి ఇక్కడ 2 times వస్తుంది ఇక్కడ అప్పుడే నీకు ఆన్సర్ వస్తుంది ఓకేనా మామూలుగా ఫ్రీ బాడీ డయాగ్రామ్ గీస్తే అక్కడ 2 పెట్టకపోతే నీకు రాదు క్లియర్ కే ఫ్లూయిడ్ ఈ మానోమీటర్ లో అక్కడ 2 ఖచ్చితంగా పెట్టాలి కే ఫ్లూయిడ్ బై m 2 క్యాన్సిల్డ్ క్లియరా క్లియర్ ఆర్ నాట్ ఇది ఫాలో అవ్వండి ఓకే ఇది అర్థమైంది కదా నౌ టెల్ మీ ఇక్కడ 2 ఉండాలి.
ఎక్కడ
దిస్ పార్ట్ కంప్లీటెడ్. Now tell me what is omega n square? Omega n square equal to G by H. Omega n equal to how much? Square root of G by H. Okay, so L equal to how much?
L is equal to 2H.
L equal to 2H. H equal to how much?
L by 2.
H equal to how much? L by 2. Omega n equal to how much? Square root of 2G by L. G by L by 2. G by L by 2. Now 2 pi by T equal to how much? Square root of 2G by L. T equal to how much? 2 pi square root of L by 2G. T equal to 2 pi square root of L by 2G, or else T equal to, from here what is obtained? From here what will get, tell me? T equal to how much is obtained? 2 pi square root of H by G. T equal to 2 pi square root of H by G. Here H is the height of the fluid column in either left limb or right limb. L is the total length of the fluid column. Total length of the fluid column. So if you want to calculate time period, 2 pi square root of m by k fluid, that equal to 2 pi square root of density of the fluid into 2 times of A into H by how much? 2 times of density of the fluid into A into G, that equal to 2 pi square root of H by G. Here we need to write 2 times of it. 2 times of density of the fluid into A into G. Understood? ఇక్కడ మనకి x రెండు వస్తాయి కదా, రెండిటికి రెండు స్ప్రింగ్ కాన్స్టెంట్. క్లియరా? ప్యారలల్. డెన్సిటీ ఆఫ్ ద ఫ్లూయిడ్ A into G into 2. ఓకే, that is the time period of oscillation in nanometers